Good morning, everybody. Today is 4.3 by Wayne. Woohoo! Okay, so 4.3, this is carbon cycling. So, off the top of my head, without looking at the syllabus, this is going to be the carbon cycle. It's going to be, there's flows, and within the carbon cycle, there's flows and sinks. And then we have methanogenesis. Oh, I gotta work on this. Methano genesis. So the production of methane, which is CH4. And we have peat formation. And I believe there's also a bit about fossils. So let's start simply with a flow and a sink, because I think this is easy. So, flow and sink. What is the largest carbon sink in the world? And that is the ocean. And then we have land. So, we have a few. There's also a word called storage. So, we have CO2 in the air. We have CO2 in the ground. This is your oil and coal. And then we have our plants, and we have our animals. Okay, so we have carbon in the air. Now, carbon in the water dissolves. So CO2 in the air becomes HCO3 minus in the water. And what this does, as an aside, as CO2 dissolves in the water, this makes the acidity go up, which actually means the pH drops. And this is called ocean acidification. There is a great opportunity here to link this to your IA, because ocean acidification is a major issue. It's not really covered in the syllabus in much detail. It just need to know the flows. So when CO2 dissolves into the water, that would be a flow or a sink. If you are thinking a flow, you are correct, because the process of dissolving, when it dissolves, that is your flow. But the ocean, if I'm talking about the ocean is a sink. So there are two major sinks on Earth for carbon. Forest and the ocean. So like the forest is considered a sink. So here's our forest, yay! And our forest has lots of taking carbon from the air. So think of it like a storage, as like there's storage and sink. So sink is where it's going into. A storage is just a storage. So the storage is like, if I break it down by like, where do we store carbon, right? Carbon is stored in plants, animals, ocean, air, ground, right? The major sinks is where it's going into. So the major sinks is the ocean and forest. And the flows, so the flow, what are some of the flows, right? We have combustion, when we burn carbon by forest fires or by man-made activities or cars or factories. They burn carbon compounds, and carbon's released into the air. There's also feeding. So this simply is going from autotroph to heterotroph, right? And I'm being sloppy here because we know these terms already. So autotroph, heterotroph. That would be another flow. Obviously, the big ones are photosynthesis, right? So this is CO2 in the air into plants. And we have respiration, which is, I would just say glucose. We have glucose, right? Becomes CO2 in the air, and that is plants and animals. So there's our big ones, right? So let's kind of like go back. So this is my carbon cycle, right? Okay, so I like doing boxes, or you can draw it out if you like, but I'm gonna do boxes. So we have animals, we have plants. This is land. This is oil. This is oceans, and then we have air. Okay, so plants, animals, that would be respiration. Air to plants, that would be photosynthesis. Air to ocean, this would be like dissolving. Plants to animals, we could just say like feeding. Or you could just say like consumption, right? Because, so, okay, so here's a quick aside to that. So you could say feeding, you could say consumption. So there's assimilation, which this is important for topic 6 and for topic 6. So carbon compounds, right, in plants are broken down. So they're broken down and then they are assimilated into animals, right? So remember topic 2 where we have glucose and sugar and lipids. All of those large organic compounds are broken down into small organic compounds and they're assimilated. So there's a few words you can use to describe this relationship. I mean, if you want to call it assimilation, feeding, consumption, it's okay. You know, you can just simply say plant animals eat plants. Okay, and then another big one that we didn't mention earlier. So from obviously what is from animals to plants and to the ground. So this would be decay, or you could say decomposition, right? And then from there, once they decay and some plants, animals don't decay and decay. So now we have fossilization. Okay, some of this carbon in the ocean. So what do we have here? We have coral. Okay, I don't know how to draw coral. So we have coral, right? So we have I think it's called calcification, right? So we're making, by taking the carbon in the ocean and we're making shells and coral. So that's another flow, right, of the carbon cycle. Okay. The last bit that is always expected on the carbon cycle drawing is a factory. So draw your factory, or draw a tree and put it on fire, right? And what is this? You have combustion. So draw a factory. So you always want to have, and you can always draw the oil rig. Woohoo, the oil rig. Doot, 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 doot. Spurting oil. Way, oil's coming out. And you can just say withdrawal. Because, better. Withdrawal. We take oil from the ground and make it into oil and burn it. So look, do you need fancy words? No, you don't. What fancy words do you really want to have? Combustion, respiration, photosynthesis, dissolve, decay, decomposition, feeding. Those are your big ones. Oh my God, this is so sloppy and messy. I don't care. But there's plenty of good pictures in your OneNote and on Google Carbon Cycle. There's tons of really good pictures. Know all these terms. Now, the next stuff. Okay, so let's see here. Going to. Okay, so back to our list. Woohoo! Back to our list. Okay, so there are methanogens. These are bacteria involved in decay or decomposition. You know what I'm saying? They're involved in decomposition, and what they do is they're bad for the environment because they increase methane in the air, which is a greenhouse gas, and that greenhouse gas is bad. So that's methanogens. Oh, this is also an anaerobic process. Okay? Link to IA and just link to, when I say link to IA, I just mean like why we care about this. So what's happening in the world? We have this permafrost all around the north of the world, and this permafrost is thawing. And as this permafrost thaws, the bacteria release more. Oh, I'm getting just worse. I'm sorry, guys. I'm just going to say it. The permafrost is thawing. There's more bacteria in the permafrost that are unthawing. There's more decay, and so as the permafrost thaws, there's more methane in the air, and it's really warming the planet. So it's kind of a positive feedback loop. There's more thawing, there's more methane being released, increases the gross temperature, and it's causing more thawing. So it's really, really bad. Great thing to investigate for your IA if you care about climate change. Or if you just care about the world, this is why it's bad the permafrost is thawing. Okay, another thing that peat. Now, you probably never heard of peat. Peat is basically in between decaying things and oil. So think of it like this. So you have your animal, okay? He dies and he decays, okay? So first he becomes peat, and then peat becomes compressed and becomes oil and coal. Okay? So peat's that in between. All you really have to know is what leads to peat. Peat is caused by acidic and or we'll make sure that's correct. It's acidic and or anaerobic and waterlogged. What does what? Oh, I should write that in answer. Okay. Waterlogged. What does waterlogged mean? Think of swamp. There's too much water in the soil. So if it's acidic and it's waterlogged, this leads to peat formation. Peat formation will eventually lead to oil and coal. Okay, this covers 4.3 in a nutshell. I think this might be my best video ever, and probably my sloppiest video ever. So I should just take a photo of this right here and just post it for you guys. So with that, I am done. 4.3 in a nutshell. Bam.